Assalamu alaikum. I am Umar Farooq, ID 22408016. Today I am present on software architectures in embedded systems. So without further delay, let's start my presentation. So, what is software architectures? Software architecture defines the structure of a system, including components, their interactions, design principles, system behavior. In embedded systems, architecture ensures efficient CPU usage, real-time response, raw power consumption, reliability. Now we'll see round-robin scheduling architecture. Actually, round-robin scheduling architecture is a CPU scheduling algorithm where each task gets equal CPU time. Tasks execute one by one in circular order, fixed time slice. Now we'll see simple example of round-robin scheduling algorithm. Given three processes P1, P2, P3, time quantum 2 microseconds or 2 milliseconds. Burst times for process 1 5 milliseconds, process 2 4 milliseconds, process 3 3 milliseconds. Now we'll solve it by step by step executions. First cycle P1 runs for 2 times because time quantum is 2 microseconds or milliseconds. Remaining 3 milliseconds. Process 2 runs for 2 milliseconds, remaining 2 milliseconds. Process 3 runs for 3 milliseconds, remaining 1 milliseconds. In second cycle, process 1 runs for 2 milliseconds and remaining 1 milliseconds. Process 2 runs for 2 milliseconds and finished because process 2 has 4 milliseconds. Process 3 runs for 1 millisecond and finished. In third cycle, process 1 runs for 1 millisecond and finished. Now we'll see the execution order or Gantt chart style. P1 0 to 2, P2 2 to 4, P3 4 to 6, P1 6 to 8, P2 8 to 10, P3 10 to 1, and P1 11 to 12. Now we'll see function queue scheduling architectures. In these architectures, tasks are stored in a queue. Scheduler picks tasks based on priority, function or execution from the queue. The types of function scheduling architecture is FIFO queues, priority queues. Now we'll see real-time operating systems architectures. Real-time operating system architectures provides deterministic task scheduling, interrupt management, and lightweight IPC primitives, essential for time-critical embedded systems. It is used for scheduler, interrupt handlers, and inter-task communications. Well, now we'll see embedded program modeling. Single processor systems actually it the model concurrency using tasks, ISRs, and state machines use UML and SysML structures to capture static structure and dynamic behaviors. It includes tasks and schedulings, interrupts, and state machines. Now we will see embedded program modeling in multiprocessor systems. Multiprocessor designs introduce synchronizations, communications patterns, and prioritize concerns critical for performance and correctness. It is used for shared memory architecture and message passing architectures. Now we'll see software development process in embedded systems. Structural lifecycle requirement, then analysis, design, then implementations, then testings, and finally integrations. Emphasis, iterations, prototyping, and verification for real-time constants. It includes requirement analysis, design modelings, implementation and testings, integration and validations. Thank you all for hearing me.